All right, let's see where we left off. I guess we could have just copied and pasted the assignment question into Chat GPT and see what we get.
That would be interesting. I heard someone talking about that. It was a whole chat.
It doesn't work. Well, I don't know how much more it needs to improve. I've seen it, gave it the final exam from your class last semester from 200. It would have easily cleared a 95 in it. Just copying the questions in and pressing enter and pasting the answers. Yeah. It's pretty scary stuff. What do I use? Online GDB? This one, Java Dungeon Crawler. So is this my current state of things? All right, so that's my current state of things. I showed you how to read something in from the user there. Now we're going to see if you listen to that lecture when I said this is really, really, really important for the double equal sign comparing strings. Remember that lecture?
Figured that out.
All right. See, sometimes my insanity is actually on purpose. All right. So what we're going to do, let's see. Does a dungeon know about the player or a room knows about the player? Player knows about the player. Okay. Does a player know about the room they're currently in? Does an inhabitant know about that? Okay, no. All right. So what we've done so far is we have in main, we've created our dungeon. We've told it to build the CS department, yada, yada, yada. We've created our player. We asked the dungeon to add our player. All right. What does that mean from a dungeon's perspective right now? Add player just takes the rooms, the starting room for this dungeon and adds the player to that. Well, what does add player for room mean? Add player for room takes the player, adds them to the correct place in the room based on the current number of players, and increments that. Yeah, player doesn't know about their room yet, is the issue. Okay, so at this point, we've taken the player, we've thrown him into the room. The room knows about the player, but the player doesn't know about the room they're currently in. Okay, so we're going to have to teach them how to remember that. Now, do just players need to know about the room they're in, or do all inhabitants need to know about the room they're in? All inhabitants, probably. Whether it's a rat or a player, they probably should know about the room they're in case they ever want to leave that room. They need to be able to talk to the room they're in to do that. So we're going to go back to inhabitant here. We're going to go ahead and we can make it a protected thing if we want, or we can say private room, current room, and then we can go ahead and give ourselves a getter and a setter for this at the inhabitant level, which would then mean that our players and monsters would get access to read write from that. All right, so we're going to go ahead and we're going to say we can really let's just make it public. So we're going to say public void, let's do public room, get current room, and this guy will return this dot current room. Then we're also going to have a public void set current room. All right, and this is going to set this dot current room equal to whatever room was passed in. So we've made a private variable inside of inhabitant called current room, and now we've given ourselves a getter to get the value of that private member, or a setter to set the value of it. Realistically, we probably want to wrap this setter in some sort of error checking, make sure you don't set it to null or something like that. to kind of show us the purpose of this. So maybe if R is not equal to null, go ahead and overwrite the current room with whatever R is. That way we don't accidentally put a inhabitant in oblivion, right? I've taken you out of this room and now you are nowhere. Good luck coming back from that. Oh. Elder Scrolls Oblivion. On sale. All right. So this would be a reason why you might set a field as private and then have a getter which gives you read-only access to it and a setter which gives you some sort of ability to ask some questions about the value before you just let them randomly set it. I'm not sure it's that important for us right here, but this is an example of why you might want to have that variable stay private and give yourself a getter and setter. All right, so now we have the ability to let a player, let any inhabitant know about the room they're currently in. So when a dungeon asks a room to add a player to it, and the dungeon says, okay, I'm going to go ahead and remember the player that now has come into this room, we're going to then say player set current room. And how do we reference the current room we're in? This. So we're going to let player P, we're going to set his current room equal to this. This is the instance of room. This is how an object refers to itself from within itself. The room is letting the player know that your current room is me. Make sense? So that's why we are letting, as we're adding the player to a room, we're letting that player know about the room they're now currently in. Okay, so now players know about the room. Make sense? So now the idea is for the assignment, we need to be able to move around in the rooms. Well, first of all, we need to add a little something here. So right now we're showing here, you're in the entrance. It shows also here, but we're not currently showing the exits. We need to know what exits are available inside this room. Well, we go back to room. The room holds a collection of exits. How many exits are there? There are number of exits. Even though we can have a maximum number of exits of 4, north, south, east, west, in our example, we will keep track of the number of exits that were actually added to this room. And if you remember, we wrote a function called addExit that took an exit as a parameter. And as long as we had less than 4 exits currently, we went ahead and we added that exit to our collection of exits and incremented the number of exits. So now when we are displaying the contents of a room, right now we're showing the room, and then we're showing the also here's the, the players that are currently in the room. We probably want to have a exit string to maybe say something like obvious exits, north and east or something like that. All right, so we're going to go ahead and say build the exit string. All right, so we're going to say string, exit string. We'll start that guy off as the empty string. We'll say for int I is equal to 0. I is less than this dot, what I call it, current number of exits. Number of exits. I plus plus, Super Ninja. All right, and we're going to go ahead and set exit string equal to whatever exit string currently is concatenated with. Can we get the direction of an exit? We currently can't. Why? If I'm looking at an exit, that field is private. Now, I don't want somebody to be able to come in and externally change the direction of an exit, but I'll go ahead and give them read-only access to that exit. So we'll add a getter here. Public string get direction. And this guy will return this dot direction. So now we can ask an exit to let us know the direction in which it goes. Okay, we've added an ability to exit. That then allows us to go back to room here and say exit string equals exit string plus this dot the exits at bucket I dot get direction. That's why I called it, right? Get direction. All right, and that is going to get us a string that is the direction in which this guy is going. And then I'll go ahead and add a little space there at the end. So we'll have a for loop that goes through and builds up those exits, you know, north space, east space, south space, whatever. And then we'll go ahead and write something out. We'll say system dot out dot println obvious exits. Oh, obvious exits, exit string. All right. So let's go ahead and run this guy again. Make sure we're now getting obvious exits. It should just be one to the north, right?
Yeah.
Room is the entrance. We have an obvious exit to the north. Also here is you. So, you know, we could maybe throw something in there that makes it so it doesn't show the current player who's interested themselves and they also here, but we're not going to do that. But we could. All right. So let me go ahead and dump all that crap. Oh, it's still running.
Yeah. I hated that so much. I have to put so much time.
All right. Now, we have to decide, this is the design decision, is when we want the player to be able to move around, who do we start that process with? Do we start the process with that player? Do we start the process with the dungeon? Do we say dungeon, make the player active? Room, make the player active? Or do we say player, go ahead and start playing? Okay, so we're going to add a function to player here. Now, does this go in player or does it go inside of inhabitant? If we're going to write the function that allows a human being to interact, to move around the map, is that something that all inhabitants should have, or is that something that just players should have? Just players, because we're going to have our monsters do more of an AI type thing, right? All right, so we're going to have a public void play, whatever here. And then we'll go ahead out in dungeon and I'm sorry, in main. And we'll go ahead and say p.play. That'll get the ball rolling for our player. All right. So now whatever we do in here, we're going to go ahead and say, for right now, I'm just going to say while true. So forever, we'll let you move around in our dungeon. Maybe we'll give some sort of a way for you to break out of this loop later on. We use the same thing we learned last semester in C++. Break, get you out of a loop. Return immediately ends a function. Same keywords. All right. So forever, we're going to ask them, what do you want to do? Or give them a prompt or something like that. All right. So we're going to go ahead and build our scanner. Scanner input is equal to a new scanner. System.in. And we need to import. One thing that a lot of IDEs will do, like for Java, is when I type in scanner there, it would have automatically imported it for you at the top. So those are like things that just make the programmer's life easier, but then I don't have to manage a whole bunch of installs. So I'll go ahead and say import java.util. Now, if you want to go lazy route, you can just say java.util.star. And that will get you everything from the util library. You know, if you want to be more specific, we say, I only right now need access to scanner. All right, makes some sense. So there's my scanner. And we want to go ahead and say system.out.println. I don't know, what do we want our prompt? Or just, what do you want to do? And we're going to actually set this as a print so it doesn't kick it down a line. All right, then we're going to read something in. So we'll say, I'm actually going to define the variable beforehand. I'm going to say string line. We'll go ahead and say line is equal to input.next line. And that will read it in. All right. And so for right now, let's just echo it back. Make sure we're in our good loop and stuff. So we'll say system.out.println, whatever they just typed. And then it's going to loop right back up and ask them, what do they want to do now? What do you want to do now? What do you want to do now? Go back to main, go to run. What do you want to do? Oh, I actually never told. I never told the dungeon to display or the room to display itself. We'll fix that here in a second. But now I can, I can type in like east, and it just echoes it back. So now I want to start asking some questions about that. But what we're going to do is the player is going to ask the current room they're in to display themselves. That's what will happen the first time through that loop each time. So before we ask them, what do you want to do? We're going to say this dot current room dot display. That's from inhabitant, right? But problem here is current room is private, which means I can only access that guy from within the inhabitant class. Now, I could make it protected, but I did give myself a get current room. So I have a getter for that guy, so I can actually extract this from my inhabitantness. I can say, where's I can say this dot get current room, and that will boil down to the current room that we're currently in. And we will have access to that variable because it is inhabitant that gave us that get current room function. An inhabitant has access to that private field. We could have just as easily made the design decision to make it protected and access everything from inside here. Okay, but we thought, you know what? It's the inhabitant that has a current room. When we need to know what room we're in, we'll go ahead and ask our inhabitantness about the room that we're in. Just a design decision we made. So we'll ask for the current room, and then we'll tell that room to display itself. All right, so there's that. And our intention would be if we hit north, it takes us to the north. Right now, it just echoes it back and shows us the room again. So now we need to ask some questions about our what they entered in here. Maybe we let them go ahead and quit by typing in quit, something like that. So we have some way of artificially exiting the program. So we say, what do you want to do? We read it in, and now we ask the question. Boom. All right, now we ask the question. If line dot equals, and I'm going to say equals ignore case. That way it'll, well, I taught you how to read the documentation, didn't I? I think I even mentioned ignore case in class. But if you don't want to use that, you could say equals. Yeah, you could say line dot two lowercase dot equals and then put in the lowercase quit. So line dot equals ignore case quit. So if we're looking at quit, we'll go ahead and do something like system.out.println. Goodbye. And then we'll break out of this loop, which will make us hit the end of play, which will then return us back to main, and we hit the end of main and the program's over. That's what happens when we type in quit. All right. So test to make sure we're comparing strings correctly now. What do you want to do? If I type in north, it does nothing. If I type in quit, it says goodbye. All right. So right now we have two options. We're going to say you either have said goodbye or you must have given me a direction. All right. And if you gave me a direction, we're going to try to take that exit in that particular direction. All right. So we'll go back into player. We're going to say else. Right now, we'll just say this. You must have given me a direction. We'll just keep that in there for right now. We'll probably ultimately have a bunch of else ifs for different things. All right. So we want to ask the room we're currently in to help us take an exit given a certain direction. Make sense? All right. So that means we need to teach room how to take an exit. Well, how to allow a player to take an exit. Player doesn't have access to the collection of exits. Room knows about the collection of exits. A player could say, room, go ahead and give me your collection of exits, and I'll just sift through and find what I want to do. You could do it that way. I mean, that's not completely unreasonable. But I would say just the object-oriented approach might be you just say, room, I'd like to go to the north. Take me. and it beams you up and all that stuff. Now, since rooms have collections of players, we probably want to go ahead and let the room know which player is trying to take the exit in which direction. So we'll go ahead, we're going to write a function here. Public void take exit. And we're going to say who is taking the exit. It's going to be a player P. And then we're going to have a string direction. All right. So we already have the player now that wants to take this exit. The room's going to have to go through and find the exit with the appropriate direction. So let's find that first. All right. So exit has a direction that's a private string, but we did give ourselves a function get direction that we use to create our exit string, and then we can use it again here. So inside of room, we're going to go ahead and spin through. We'll say exit. The exit will just be verbose here to take. We'll start that off at null. Right now, we don't actually have an exit to take. We're going to go and search for the exit we want to take. So now we'll have a for loop for int I is equal to 0. I is less than this dot number of exits. I plus plus. Each time through, we want to ask the question, is the exit we're currently looking at equal to the direction that we want to go? So if this dot the exits at bucket I, that is an instance of exit, dot get direction, that is the direction associated with that exit, dot equals, if we want to let them type in north, south, east, west, upper or lowercase, we'll do ignore case again. So if this exit's direction is equal to, ignoring case, the direction you wanted to go. If that's true, we'll go ahead and set the exit to take equal to this dot, the exits at bucket I. You want to say, can I do this? In this particular case, it will work. But if you remember when we looked at it in class, we had like a string S1, S2, S3, and I built a couple of those strings by saying new string, which got technically different memory addresses. The double equal sign is the primitive equivalence operator. So if I'm saying, give me the string version of the direction, and this won't ignore case, by the way, and compare it to the direction they entered, let me know if it is the same memory address. And the only way it would be the same memory address is if they were using the string literal. That is, they never use the new keyword with it, which would be the case in this case. So that's what makes this dangerous, because in this case, you actually would get the result you wanted, but sort of kind of for the wrong reason. You wanted to know, did the exit they typed in, did north equal north? But that's not what you actually checked. You said, does the memory address associated with the north string literal equal the memory address with the direction that's equal to the north string literal? In that particular case, it would match, but for the wrong reason. You're not comparing contents, you're comparing location. So if you're comparing strings, chances are you're caring about the contents of those strings. You definitely want to use the dot equals methods. Plus, now we have the ability to say, I want to check to see if it's a equals ignore case, so they can type in north in upper lower case, or a randomization of both, whatever. Or you can just convert everything to lowercase on both sides and just do dot equals if you like that, or convert both sides to uppercase, whatever. All right. So if the exit we're currently looking at, when getting its direction, equals, ignoring case, the direction you want to go, then we'll go ahead and set our variable, the exit we want to take, this guy right here that started off as null. We'll start it off at, well, we'll set it equal to, we'll overwrite it with the actual exit we found. Since we did find the exit here, we'll go ahead and tell it to break. We don't need to keep looking, right? We loop through our exits. We finally found the exit we were interested in. We don't need to look at any more exits. So let's get out of that loop. That's what break does. So break's going to put us right here, following the for loop. Did we? Well, I thought you said Java was having a problem, and why does it sometimes not run?
Well, all I had to do was
It wasn't working before because you had bad code. Not the first time you've had bad code. I've had bad code, except in this class. I only have bad code when I purposely put an error in. So you guys have to. Yeah, it's a thing. I made all my errors, or most of my errors, 30 years ago, but believe me, there's wounds, there's scars. They run deep. All right, so did we find an exit? So we'll ask the question, if the exit to take is not equal to null, that means we found an exit, right? Well, here, I'm going to actually ask, is it equal to null? If it's equal to null, we're going to say system dot out dot println. Actually, have we been using system.err? All right, because this is an error, right? Only if you chose to have it go to like a log file. In our case here, they're going to be, I'm guessing it's even in the same color. So as opposed to it showing up in red down here, I guess we'll find out. So system.err.println exit not found, something like that. Else we did find an exit and we want to go ahead and take that exit. All right. So for right now, let's just make sure our logic is working so far. Actually, I'm going to go back in here real quick. We'll say doing it on purpose. All right, so we're going to take the exit there. Go ahead and run this guy. All right. All right, so what do you want to do? We're going to take the random exit. It's hard to pronounce. I have to use the old I don't know, the old language. Yells at us, says oh, it actually suppresses system.err. You don't even see it. Jerks. All right.
How did you change it to code? It's like some, I think it's like an exit or something.
Oh, wow. We're not going to go that deep into this. I understand. All right, so we'll bring their attention to this.
Yeah.
All right, perfect. Oh, hold on. We never actually called take exit. So actually the system.err probably does work. In fact, I want to switch it back.
I saw it.
And you guys' homework over a weekend is getting way worse too. All right. So right here, we're saying you must have given me a direction. So we need to say this dot, what I call it, current room, get current room. Get current room dot take exit. And then we're going to pass in the direction we typed in line. We're in player. Oh, for take exit. Thank you. So pass ourselves in along with the direction because we wrote take exit to take in who's taking the exit and what direction are they going. All right. So now, since we're trying to actually take the exit after we found the exit, here, run. All right, exit not found. There's system.err. It's not in red or anything, yada, 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 whatever. All right, but now we're going to say, let's go to the north instead. And now it's saying, hey, I recognize that you told me a real place. So let's actually take the exit. What does it mean to take an exit? It means get the player out of the current room, put the player into the new room, and let the player know that they're in a new room. Make sense? Now, for room, when we add player, we are already letting the player know that they're now in a new room. All right, so we're already doing the adding player to a room portion of this. All right, but we need to get the player out of the current room before we can add them to that next room, which means we need to go through our list of players and we need to find that player so that we can add them to the room. Now, well, not just find the player, we need to erase the player from the room. And this is where it becomes a problem because we've written our thing to have a collection of players. So right now, this player is at bucket 0. Now, when I remove him from bucket 0, what does it mean to remove him from bucket 0? Well, I can throw a null there, right? But then later on, I have to, when I'm building my player string, I need to make sure I check for nulls. That way I don't concatenate on a string of nothingness. All right. So this is all part of the puzzle because of these design decisions we made. Since we chose to use an array, arrays are not changeable. Our array of players, I think we say can hold 25 players. I currently have only put one player in there. But if I want that player gone, well, I can say, well, I'll just overwrite bucket 0 with a null. But now next time we go and try to calculate our player string for who else is here, the very first bucket it looks at for us right now is going to just be null, right? There's nobody else here. But I need to make sure I deal with the nulls. Go ahead. Let's say we had 4 players in the room, right? And we just removed the player at bucket 0. Now we have 3 players in the room, but bucket 0 is still null. Bucket 1, 2, 3. Now, to make what you said work, we could shift all the other players down, right? Which is fine. You can do that. It's not the end of the world. You can just shift everything forward by 1, which is fine. In fact, that probably gives you the better consequence because that allows you to, when we add players to room in bulk, you won't have the problem of where to add them. So we could leave our thing alone right now, where when we go to remove the player from this room. So where's my take exit? Take exit. So right here is where we're going to take that exit. So the first thing we're going to do is we're going to say remove player from this room. And I'm going to go ahead and I'm going to write a function to do that. Now, I am handling my players and monsters separately, right? Yeah, I am. So we're going to say private void remove player from room. This guy will take in a player P as a parameter. Now my goal is to find the player, set that bucket to null, decrement the number of players in there. And if we want this to be compatible with the way we've already written it without having to change anything else, probably shift all players that came after that bucket forward 1 to fill in the gap of the guy we just removed, even though we only have 1 guy in here. So this code actually is not going to get called. All right. So first thing first, find the bucket where the player is. Orient I is equal to 0. I is less than this dot the current number of players. I plus plus. Okay, so if this dot the players at bucket I is equivalent to P, is the double equal sign the correct thing to use right here? It's the correct thing to use. I'm not looking for the player with the same name. I'm looking for the same player, right? Do these dudes have the same memory address? I exactly want to use the double equal sign here. So it's important that we understand the double equal sign is not a waste of time when it comes to objects. It's just asking a very specific question. We're comparing memory addresses, not the contents of the object. You could have 2 separate players, both named Mike, and the double equal sign will be false when comparing those. Because we don't care that we have 2 different people named Mike. We want to know, is this player the same player that we want to remove? We actually don't even care what their name is. Okay? Are you the dude that's getting out of here? Then get out of here. All right. So we want to use the double equal sign for comparing these guys. So if we're looking at the correct player here, then what do I want to do? Well, I need him out of this room. So I can go ahead and I can just set its bucket to null. Or what I can do is I can just go to the next player in line and shift everything from there to the end back 1. overwriting it, correct? So I can create another for loop in here, which this is going to start getting fun. So I can say for int j is equal to, I want to start at the bucket that is one bucket further than my current position I'm looking at, which is bucket I. So that's I plus 1. Nailed it. Okay, so we just found the player right here that we want to get rid of. So we're going to start at this player. And we're going to just start shifting those guys to the left 1. All right. So the very first time through, we never even set the player we wanted to remove to null. We're just going to overwrite them. Okay, so j is equal to I plus 1. Keep going as long as j is less than current number of players. I like saying this dot, current number of players, even though it wasn't required. J plus plus, each time through, what are we going to say? This dot, the players at bucket j minus 1 is equal to this dot, the players at bucket j. So we'll just shift them left 1 all the way to the final number of players, right? You know, so we overwrote the player we're removing. We didn't actually remove him. We just, I don't know, deleted him from existence by overwriting him and saying, you're not even worth remembering. All right. So that's what this inner loop will do. Once we've shifted everything over, we then want to remember that current number of players is now 1 smaller than it used to be. Now, effectively at this point, we have removed the player from the room, have we? Have we not? Find the player you want to remove. He's at bucket I. Then go to bucket I plus 1. And from there to the rest of the players, shift everybody over by 1, closing the gap, right? Then make sure we say, oh, we now have 1 less player than we used to have, decrement it. And now I want to get out of Dodge. Return. Return makes a function immediately end. I don't want to loop through this outer loop again. I found the player I was interested in. Found the player, shifted all the other players. Now that this guy is going to be gone, decremented my current number of players, end the function. Make sense? The only way this function dies of a natural death is if I search through here and never actually find the player I was searching for. Then this for loop will run to its fruition and the method would just end. Well, that's true. You know, and we could do something like, you know, write something like player, you know, like Mike has left to the north or something, but remove player, we've got pretty generic here. All right, so remove player from room. This is what this guy will do. All right. This dot remove player from room. Who's the player we want to remove from the room? Who is the player we want to remove from the room? All right. Then after, so we have found the exit we want to take, right? So if the exit is null, that means we didn't find the exit. Otherwise, we found the exit we want to take. We remove the player from this current room and we add the player to that exit. Public void add player. Player P. And what room is that player going to be added to? Destination room. This dot destination room dot add player P. It's now inside of room here. We'll go ahead and say, what do I call it? The exit to take. The exit to take dot add, I call it add player or take exit. All right. So when I remove the player from the room, it will reduce the players in this current room by 1 and shift everything over. When I add the player to this exit, the player will then set this destinations room, will ask the destination room to add the player. The destination room goes ahead and sets the player in its array of players, but then lets the player know that they are now in this new room. And then when we loop back up inside a player, and it says this current room display, you should be displaying information about a new room. Because all that rigmarole when we just went to the north involved him getting yanked out of the current room, taking an exit to a next room, put into a next room where that room lets him know about the new room he's in. All right. So also here to the north. So we're going to go ahead and say, let's go to the north. So now we're in our next room, room H1. We can go back to the south. Now we're back in the entrance. We can go to the north. We can go, then we can go to the north again. Then we can go to the east. We go to the east. Then we can go to the north. And now we're in this room right here. Make sense? So I think, does that complete the stuff for today? All right, questions about any of that? Now, the point so we're starting to do things that are, a little bit bigger in scope now. But what I want you to see from this is we let it grow organically, and we said, who needs to know about what, and who do I need to rely on? Who's going to help me get this player out of the room? And then we went and added those abilities to, let's say, the right place when we needed it, as opposed to try to solve all the world's problems right up front and then have all these functions that we maybe never use or actually need to take a different kind of parameter. All right. So what we're going to do on Monday is we're going to introduce threads and get our rats moving around. Hopefully we finish that Monday. Wednesday at the worst. Then we'll introduce Unity. And then we're going to convert all this code over to C#, which is not going to take a whole lot, and have this be the backbone, the controller for actual things running around in a dungeon on the screen using, of course, between 4 and 8K graphics. I mean, 4 and 8-bit graphics. All right, questions, comments, concerns, bribes. All right, I'll put a link up to the code. No homework over the weekend. Except study this and make sure you understand what we just did. Well, I'll probably still be in there until I have lunch with Dr. Wall right now, so probably 1 o'clock I'll be in there. But in general, if you need to meet with me, just send me a Slack message and we'll set it up, because I'm in and out randomly.
So these are my codes for the colors. You know, like what kind of things these are?
Oh yeah, those are ANSI codes. So what it does is it lets the terminal know that it lets the terminal know to go into that mode. Your terminal has to be ANSI compliant, which most are. That's a really old school thing that they used in old text-based games to have different colors on the screen. But you effectively tell it to convert into blue text mode. It's like giving it a directive.
Makes sense.